In the church?
Alright guys, so today is Friday. Yesterday we did some problems with dilations, working with transformations. Today we're going to once again work in our 8th grade strategy booklets, our Staar blue booklets, so our warm-up booklets. And today we're going to start on page 47, and we're going to start on number 11. And today we're going to be working with all the other types of transformations that we have. Okay, so yesterday we worked with dilations. Today we're going to be working with rotations, reflections, and translations. Okay, and so once again, everything will be number 11. You will have problem 11, 11A, 11B, 11C, 11D, and 11E will be what our goal is today to get through. Okay, and so once again, on the first problem, you see the strategy with tracing paper. You can do it with tracing paper. Or you can do it by the motion rule. I'm going to show you both strategies so you can kind of pick which one you want. And of course, I do have tracing paper available to you. That way, if you do want to use it, you can, and you are allowed to use it on the STAR test. Okay, so definitely you can use it. It makes your life easier for some of you. And it is a tool now that they are allowing you to use on the STAR test. Originally, you weren't allowed to use it, but now you are. So I am going to provide it for you, and I am going to show you the strategy. Alright, so I have my patty paper, okay, and all you're going to do is you're going to take this patty paper, you're going to put it right over your graph. Okay, and so you're going to follow a step. It says, pick a point from the figure and write it somewhere beneath the graph. Okay, so we could do that. We could take point D, for example. That's what they take. Okay, and point D is at 6, 5. Okay. Then it says step 2, trace and label the figure onto tracing paper and mark the origin. So this is key. Marking the origin is key. Okay, and so I'm going to put my patty paper here and I'm going to mark the origin just like this. Draw a nice big circle right on the center of my graph. Okay, and then I'm going to trace. So I've got to kind of push this flat, and I'm going to trace the shape. Just like this. Okay, so I've marked the origin, okay, and I have traced my shape. Now it says step 3, a 90-degree rotation counterclockwise, okay, is a 1/4 turn to the left. So counterclockwise, I'm going in this direction, opposite of the clock. If it said clockwise, I'd be going in this direction. But it says counterclockwise, so I'm going to turn 90 degrees, okay, to the left. All right, and so this is how I would do that. I would just stay on the origin. Okay, and I'm literally just turning my paper like this. Okay, and so now I see my shape, and I see exactly where it is. It's going to be around this point, on this point, and on this point. Okay, so step 4, it says, what are the coordinates of your point once you have turned the tracing paper? Well, if I look at D prime, okay, so really important too that, so if I move it back, right, if I move it back, okay, you also want to label the points, right? So this is D, O, and G. Okay, so now when I actually rotate it 90 degrees, again, I've got to get my origin right on there. And I got to make sure my paper's straight too. Okay, so when I rotate 90 degrees, I can look at any of my letters. So I have D, O, and G. So now this is D prime, O prime, and G prime. Okay, and let me zoom in so you can see that a little bit better. Okay, but this is now D prime, O prime, and G prime. I can see D prime is going to be at -5, 6. Okay, and so D prime negative 5, comma 6. Okay, and so that is how you use patty paper. Okay, and for example, let's say I wanted to go 180. Well, if I was going, it wouldn't matter if I was going clockwise or counterclockwise because you'd end up at the same spot. But I would go 90 once, then I would go 180, then I would go 270, and then I could go 360, which would take me back to my original shape. Okay, so using tracing and patty paper is a fantastic strategy that you are now allowed to use on the STAR test. So it is something I do want you to practice because, you know, it's not necessarily easy to memorize the motion rules. Okay, I've taught you what you need to do if you want to memorize the motion rules, and you can if you want. Like, for example, you know, you could memorize that it's, you know, negative y comma x. That's the motion rule for a 90 degrees counterclockwise rotation. Okay, but if you don't memorize that, okay, you can always use patty paper, and it's simply just tracing. Okay, nothing too difficult. All right, and so what I can do here now, it's asking me which rule describes this transformation. Well, if I look at...
Please come to the front office. Victoria Hahn, please come to the front office.
Victoria Hahn, you better get to the office. Anyway, if I look at my x and y coordinate, okay, I can ask myself, well, what happened to them? Well, x and y switched, right? 6 went over here, and 5 went over here, but y became the opposite. Okay, and so this is my answer, which looks like letter D. Okay, and that is the motion rule for a 90 degrees counterclockwise rotation. Okay? The other thing you could do too is you can look at your answer choices, right? And this one, actually, you could have eliminated some answer choices. Here, this is a reflection across the y-axis because y stays the same. This right here is a reflection across the x-axis because x stays the same. So A and C you could have eliminated immediately because these are the motion rules for reflections. Right? This one's reflection over y-axis. This one's reflection over x-axis. Okay? So A and C you could have eliminated immediately. This right here, this motion rule does not exist. Y comma x. When x and y just switch, that motion rule does not exist. Okay, and so this one you can eliminate because you know it's not one of your motion rules. So process of elimination, you could have chosen D, right? Or you could have done the patty paper strategy that we did. The strategy it gives you over here. Okay, and step 5 is pretty much what I did here, which is where I compared the 2 points, and I saw how x and y changed. Well, 6 and 5 switch spots, so x and y switch spots. And the y becomes the opposite, so y becomes the opposite. Notice how x stayed the same. 6 is still 6, so x is still x. Okay? Moving on to problem 11a. So 11a, if triangle dog, DOG, is rotated 270 degrees, it's actually the same triangle, so I can actually put my patty paper back on here. Okay, it says which rule describes this transformation? Okay, well, all I got to do is rotate 270 degrees, but now it's clockwise, so it's a little bit different. Counterclockwise, we went this way. Clockwise, we're going this way. So I'm going to go 90, 180, and 270. And look at that, we actually end up at the same place as the last problem. The reason why is because a 90 degrees counterclockwise rotation is the same as a 270 degrees clockwise rotation. Hence, we should have the same motion rule. which in this case is, once again, negative y comma x. So C was my answer. Okay, and I can, once again, compare the points, right? If I have my patty paper here, I can look at a different point if I want to, right? I could look at, say, point G prime. That's at 2, 5. Okay, so G prime is at 2, 5. Okay, G is at 5, negative 2. Okay, so if this is my xy, well, I have to see what happened. Well, it looks like x and y switch spots. Okay, and my y became the opposite. It was negative 2, now it's positive 2. And so it is the same motion rule. Once again, you will have this motion rule that does not exist. And once again, you have a reflection across the y-axis and a reflection across the x-axis. And so both of these reflections you can eliminate. And so just by elimination, you can get C, or you can also do the patty paper strategy with the rotations. Remember, a rotation, all the shape is doing, guys, the shape is not changing size, it's not changing shape, it is literally just spinning. As if you were taking this and turning a doorknob. Right? You're turning the doorknob, you're turning the doorknob, you're turning the doorknob. Eventually you turn it all the way around until it hits. And a great way, too, to keep this in place is maybe stick your pencil right here. Let's see if this works. Stick my pencil here, and then I can just do this. Just kind of spin the paper. Right? That way you keep your paper on the center. Okay, and I know my hands are kind of in the way there, but let's see if I can maybe just put a finger here, and then you can spin it. Right, until it gets even. Okay, so that'd be 180. And I could spin it again. Right, and that would be 270. Then I could spin it again, and that would be 360. Awesome. Number 11B, I'm going to give you a few minutes to do on your own because 11B is 180. And so I'm going to let you figure out which one of these is the correct rule that describes the transformation. You can take that same patty paper and you can go 180. Okay, and you can go clockwise, or subsequently you can go counterclockwise because you will end up at the same spot because you're just going either halfway this way or you're going halfway this way. Okay. All right, so now you've had a few minutes to do problem 11B. We're going to go into 11C. So 11C says a figure is graphed on a coordinate grid as shown. I'm going to have my patty paper ready. Get me a new piece. Okay, so each of you should now have a new piece of patty paper. The figure is rotated 90 degrees clockwise with the origin as the center of rotation to create a new figure. Which rule describes the transformation? So I can take my patty paper, put it over here. Once again, I'm going to mark my origin. Okay, and then I'm going to trace my shape. Okay, make sure your paper is flat, it doesn't move around. Okay, and that way you get a good trace. Okay, so I'm going to move 90 degrees clockwise. So I like to put my pencil here, hold it down, and I'm just going to rotate my paper 90 degrees clockwise. Okay, and so I've rotated my paper at 90 degrees clockwise. All right, and so I can look at my points here. I'm going to pretend that this right here is point A. Okay, and point A we're going to say is at 3, -4. So right over here I'm going to write that my x, y is 3, -4. Okay, and I'm going to look at my new coordinate, which the corresponding coordinate to this one would be this one at -4, -3. And so I've got to look and I've got to see what happened to x and what happened to y. Well, x and y switched spots, so we know that. So x and y are going to switch spots. Okay? And then x became the opposite, and y stayed the same. X became the opposite, y stayed the same. So I'm going to erase this and rewrite it so it looks a little bit neater. Okay, but y and x switched spots, and x became the opposite. So y negative x is going to be my motion rule for this 90 degrees clockwise transformation. Okay, so I look at my answer choices, and I see y negative x. Okay, right here, negative yx, that would be 90 degrees counterclockwise. So don't let that trick you. Okay, this right here is another reflection, and so is this. Remember, reflection over the y-axis, y stays the same. Reflection over the x-axis, x stays the same. Okay? All right. And I'm going to let you do 11D on your own. I kind of almost answered it here for you on 11C. But 11D, I'm going to let you do, okay, because it is the same thing. Now you're just going 90 degrees counterclockwise. Okay? So I'm going to let you do that one. And we'll come back in a couple minutes and move forward. Alright, so you've had a couple minutes to do problem 11D, and now we're going to do problem 11E. 11E is a little bit different. Okay, so we mostly just did rotations, and now we're going to do a reflection. It says the coordinates of vertices of a triangle are P, Q, and R. P is at negative 5, 0, so negative 5, 0 is right there. And then we have negative 2, 3, which is right there. And we have, I'm sorry, that was negative 2, yes, positive 3. Then we have negative 2, negative 3. Okay, so I've got this lovely triangle. Okay, and this is triangle P, so P would go here, and Q would go here, and R would go here. Okay, so this is triangle PQR. Okay, and so triangle PQR is reflected across the x-axis to create triangle P prime, Q prime, R prime. Now, a reflection across the x-axis, x stays the same. Very easy way to remember it. And so this is my motion rule. Reflection across the x-axis, x stays the same. So y just becomes the opposite. Okay, so your answer is letter A. But if we actually wanted to do the reflection, it's very, very simple. Okay, and you don't even need patty paper for it. This right here, your x-axis, okay, reflection across the x-axis. Okay, so you got to look at your x-axis. That is your line of symmetry. Okay, and so this one's a little bit unique because it's already kind of halfway on there. But the best way to do it, once again, is to plot the points, to do the coordinates. So we already have the coordinates up here, so we're going to apply the motion rule. So if I have negative 5, 0, and I know that x stays the same, well, if x is negative 5, then x is going to be negative 5, and y is going to be the opposite. Now, in this case, y is 0. The opposite of 0 is 0. So in this case, the point would be the same. If we look at, that's point P, if we look at point Q, we would have negative 2, 3. Okay, and so x stays the same, so x is negative 2. But now y is the opposite, so y is 3, so the opposite of y is negative 3. Okay? And r is negative 2, negative 3. Okay? And so x stays the same, but now y is negative 3, so the opposite of y is positive 3. So this reflection is actually kind of special because it's already symmetrical to the x-axis. So really what's happening is, really R and Q are just kind of switching spots. It's kind of like if I took it and flipped the triangle like a pancake, that's really what's happening here. P is staying in the same spot, right? But R is being flipped over here, and Q is being flipped over here. And if you notice, see how this is P prime, Q prime, and R prime. P is staying in the same spot because this is being flipped, right? But now Q prime, okay, is what R was, and R prime is what Q was because it's just being flipped over. Okay, depending on where the shape is at, okay, this normally doesn't happen. Okay, but in this case, since it's a reflection over the x-axis, it did happen. Normally, what you can do is, like, for example, say this was a reflection over the y-axis. Well, the y-axis would be the line of symmetry. So all you have to do is mirror the shape. So if Q is 2 spots away from the y-axis, right, then Q prime would be here. And if P is 5 spots away, you literally just mirror it. Okay, so this would be a reflection across the y-axis, okay, but I can't draw the reflection across the x-axis because it's the same triangle. You're literally just taking it and flipping it this way. You're flipping it like a pancake. Here, you're flipping it like a book to get to the y-axis. Okay? All right. This is all we have for today with reflections and rotations. Okay, so you have 2 types of reflections, right? We have reflection over the x-axis, reflection over the y-axis, which we just showed you. Okay, you have the motion rules in your ISN. Okay, and for rotations, once again, it's very simple. Use this patty paper. Okay, you are now officially allowed to use it on the STAR test. Okay, so I expect you to take advantage of it, and I expect you to utilize it because it does make your life a lot easier. Okay, just make sure that you use it correctly, you mark the origin, and that you spin your paper accordingly. Okay? Please turn in your STAR booklets to the substitute. Make sure your name and class period is on them. Okay, and once we finish these booklets, we'll do more on Monday. Once we finish these booklets, we will allow you to take them home so you can study them, so you can look at them. And, of course, all these videos on the STAR booklets will be posted on YouTube, on my YouTube channel, Eisenberg Productions. Have a nice weekend, guys. See you Monday.